We'll start in about a minute. All right, it's time to start. Today and tomorrow we'll go over the test 2 review. And the test 2 is over what we've covered from chapters 4, 5, and 6. Test 2 will be on Thursday. And tomorrow I will send information about the Zoom meeting for the test. Okay, in the first page, solve each system of linear equations and identify each as consistent or inconsistent. So we always have two methods for solving a system of two linear equations. One is the substitution method, and the other one is the addition method. So in this first one on the left, well, we can use the addition method if I multiply both sides of the top equation by -3. So when we multiply every term on both sides of the top equation by -3, we get -6x minus 27y equals +12. And then multiply every term on both sides of the bottom equation by +2. Multiply by 2, we get 6x plus 26y equals -14. When we add these two equations together, the variable x is eliminated. And then -27y plus 26y is -y. And 12 plus -14 is -2. So if -y equals -2, y equals +2. And to find the x coordinate, we can use any one of the equations. So I'll pick the top equation, 2x plus 9y equals -4, and replace y with 2. So we get 2x plus 9 times 2 equals -4. Or 2x plus 18 equals -4. Subtract 18 from both sides, we get 2x equals -22, and then divide both sides by 2, we get x equals -11. So as an ordered pair, the solution xy, the ordered pair xy is -11 for x and 2 for y. So anytime a system of two linear equations has one solution or infinitely many, the system is consistent. Okay, the next set, or the next pair of linear equations, this one is set up nicely to apply the substitution method, since the top equation is y equals -2x minus 2. So in the second equation, replace y with negative 2x minus 2. And then we'll solve this for x. So we get 7x minus 6x minus 6 equals negative 9. And we could do a couple of things at once. We can simplify 7x minus 6x. We can also add 6 to both sides. So 7x minus 6x is x. And when we add 6 to both sides, negative 9 plus 6 is negative 3. And now that we know that x equals negative 3, we can use the top equation to solve for y. So in this equation, replace x with negative 3. We get y equals negative 2 times negative 3 minus 2, or y equals 6 minus 2, and so y equals 4. The ordered pair solution is negative 3 for x and 4 for y. So this system is also consistent because it has a solution. Okay, the next pair of linear equations, I should say the next system of two linear equations, 2x plus y equals 3, and 4x plus 2y equals 6. Okay, we can use substitution or addition. I'm going to leave the top equation exactly the way it is, and then divide every term on both sides of the bottom equation by negative 2. Divide by negative 2. So the top equation stays the same, 2x plus y equals 3. Divide every term on both sides of the bottom equation by negative 2. And we get negative 2x minus y equals negative 3. And when we add these two equations together, 2x plus negative 2x is 0. Y plus negative y is 0. 3 plus negative 3 is 0. This is true. So the system is consistent, but it has infinitely many solutions. The two lines are exactly the same line. So the system has infinitely many solutions. So that kind of system is consistent. Okay, the next system, x minus 2y equals 5, and negative 2x plus 4y equals 6. Well, if we multiply both sides of the top equation by 2, and leave the bottom equation the same, we'll get 2x minus 4y equals 10. And negative 2x plus 4y equals 6. When we add these equations, 2x plus negative 2x is 0. Negative 4y plus 4y is 0. And on the right-hand side, 10 plus 6 is 16. So that's false. 0 equals 16 is false. So this system has no solution. That means the two lines are parallel. They have the same slope, but different y-intercepts. So since there's no solution, the system is inconsistent. Okay, the next problem is number 2, a word problem. A boat traveled 12 miles down a river in 3 hours, and it traveled 12 miles up the river in 6 hours. Find the rate of the boat and the rate of the current. So with word problems, we assign variables. So I'll assign capital B to be the rate of the boat in miles per hour. So the boat's rate in miles per hour. And C is the rate of the current, also measured in miles per hour. So the current's rate in miles per hour. And there are 2 scenarios described. The boat, in one case, travels down a river. That means going with the current. And the other case is the boat traveling up the river, which is against the current. So for each of those, we'll write down an equation having the form rate times time equals distance. So this is one of those problems, rate times time equals distance. Okay, so with the current in one case and against the current in the second case. Okay, if the boat is going with the current, then the rate, overall rate, is the boat's rate plus the rate of the current. And we're told that going down the river with the current, it travels 12 miles in 3 hours. Okay, so this has the form rate times time equals distance. So that's one of our equations. When the boat is going against the current, it will only be moving at B minus C miles per hour. And we're told that when it's going up the river or against the current, in 6 hours, it travels 12 miles. Okay, so here is our system. The top equation, we can divide both sides by 3 to get B plus C equals 4. And the bottom equation, we can divide both sides by 6, and we get B minus C equals 2. And when we add these 2 equations, the variable C is eliminated, and we get 2B equals 6. Then divide by 2, we get B equals 3. And then to find the speed of the current, we can use any one of the other equations. So I'll use this one, B plus C equals 4. Replace B with 3, we get 3 plus C equals 4. And so C equals 1. Okay, so when we say the boat travels at a certain rate, we are referring to how fast the boat would be traveling in still water if there was no current. So to summarize, the boat's rate in still water when there's no current is 3 miles per hour. And the rate of the current, or the current's rate, is 1 mile per hour. Okay, that's all there is to that. Okay, the next problem, we have 3 more word problems. Okay, this one, number 3. Jason purchased 3 pies and 4 drinks for $23. And Julie purchased 2 pies and 5 drinks for $20. Find the cost for each pie and each drink. Okay, find the cost for each pie and each drink. So we assign variables to represent the things that we want to find. So we can use any variables we want. So I'll use capital P for the cost of a pie, the cost of each pie, and I'll use capital D for the cost of each drink. Okay, so for Jason purchased 3 pies and 4 drinks for $23. So if the cost of each pie is $P, then, and Jason bought 3 pies, then he pays 3 times P for the pies and 4 times D for the drinks, and the total is $23. And Julie purchased 2 pies and 5 drinks for $20. So we have a system of 2 linear equations. We can use the substitution method, or we can use the addition method. So I'll try to make sure the letter D doesn't look like the number 0. So I think I prefer the addition method on this one. So I'm going to multiply the top equation by -2, and the bottom equation I'll multiply on both sides by +3. Okay, when I multiply every term on both sides of the top equation by -2, I get -6p minus 8d equals -46. And then multiply every term on both sides of the bottom equation by 3, I get 6p plus 15d equals 60. And when I add these 2 equations, the variable p is eliminated. -8d plus 15d is 7d. And on the right-hand side, -46 plus 60 is 14. And so D is equal to $2. So each drink is $2. And then to find the cost of each pi, I can use any one of the equations, any one of those four. So I'll just pick this equation and replace d with $2. So 2 times p plus 5 times 2 equals 20. So this is 10. I'll subtract 10 from both sides, and we get 2p equals 10. And the cost of each pi is $5. Hey, I don't have a lot of space, but if I did, I would write the cost of each pie is $5 and the cost of each drink is $2. Hey, the next problem, Jackson invested $32,000, part at the annual interest rate of 6%, and the rest at the annual interest rate of 8%. After 1 year, he received $2,060 in interest. Find the amount of money that was invested at each interest rate. Okay, so I'll pick X to be the number of dollars or the amount that was invested at 6%. Amount invested at 6%. And I'll pick Y to be the amount invested at 8%. Okay, so we can write down two equations. The total amount invested is $32,000. So one of the equations is X plus Y equals 32,000. Each term represents a certain amount of money that was invested. In the second equation, every term will represent an amount of interest. So after 1 year, X dollars earning interest at 6% per year will earn 0.06X dollars in interest. And Y dollars at 8% per year will earn 0.08 times Y dollars. And we're told that the total amount of interest from both accounts after 1 year is $2,060. Okay, there's a few things that we can do. We could get rid of the decimal numbers if we multiply every term on both sides of the bottom equation by 100. And then we could make the coefficients smaller by dividing everything by 2 after that. Or we can just use substitution directly. So let's try that. I'll solve the top equation for y. Y equals 32,000 minus x. And in the bottom equation, I'll replace y with 32,000 minus x. And then with the help of a high-powered calculator, you can solve this equation for y. So I'll take it a couple of steps further. So we have 0.06x, and then 0.08 times 32,000 let's see, 256 with 2 zeros. So I get, when I multiply 0.08 times 32,000, 240, 256, yeah, I get 25,600, and then minus 0.08x equals, did I do that right? This is not right. This is just 2,560. Yeah, sorry. I have one too many zeros there. And then minus 0.08x equals 2,060. Then if we combine like terms, 0.06x minus 0.08x, I get negative 0.02x. And if I subtract 2,560 from both sides, I'm going to get negative 500. And then if we divide both sides by negative 0.02, so a negative divided by a negative is a positive, so I can write it as 500 divided by 0.02. So that's going to be 25,000 when I simplify. Okay, then if x is 25,000 and x plus y is 32,000, then y is 7,000. So you might want to check my arithmetic. One way to check it is to use the second equation. If you multiply 25,000 by 0.06 and add that to 7,000 times 0.08, if it's correct, it will add up to 2,060. So I'll mention that. One way to check is multiply 0.06 times 25,000. Add that to 0.08 times 7,000. And check to see that that's equal to the total amount of interest, 2,060. So let's see, 0.06 times 25,000, that's 1,500. And 0.08 times 7,000 is 560. So at least the way I did it, I got the correct answers. Okay, let's move on to the next problem. 100 liters of a 6% acid solution is needed. Find the number of liters of a 5% acid solution and a 10% acid solution. Looks like the wording of this problem is a little strange. Let's see. 100 liters of a 6% acid solution is needed. Okay, find the number of liters of a 5% acid solution and a 10% acid solution that would give us 100 liters of a 6% solution. Okay, find the number of liters of a 5% acid solution and also find the number of liters of a 10% acid solution, so that we end up with 100 liters of a 6% acid solution. So we can pick X to be the number of liters that's 5% acid. So number of liters that is 5% acid. And I'll pick Y to be the number of liters that is 10% acid. Altogether, we need 100 liters, so X liters plus Y liters is 100. And the amount of acid has to be 6%. So if X liters is 5% acid, then the amount of acid in those X liters is found by multiplying 0.05 times X. That's the amount of pure acid in X liters. Then Y liters is 10% acid, so the amount of acid is 0.10 times Y. And in the mixture, the amount of acid in the 100 liters is found by multiplying 0.06 times 100. Okay, on this one, let's do a couple of things. Let's make this bottom equation simpler. If we multiply every term on both sides by 100, we'll get 5x plus 10y equals 600. And then we can divide every term on both sides by 5. So if we divide every term on both sides by 5, we get x plus 2y equals 120. Okay, so the top equation, I'll multiply both sides by -1, multiply by -1 to get negative x minus y equals -100. And I'll leave this one the same, x plus 2y equals 120. X plus 2y equals 120. When we add these two equations, the variable x is eliminated. Negative y plus 2y is y. Negative 100 plus 120 is 20. And since x plus y equals 100, we can see easily that x equals 80. Okay, so 80 liters of the 5% acid solution. 20 liters of the 10% acid solution. Are needed. So we'll leave it at that. But they're needed to get 100 liters, that is 6% acid. All right, let's move on to the next page. Simplify the expressions. Use positive exponents only in the answers. So the print is pretty small. So on the inside of the parentheses, let's simplify what we have there. So in the numerator, we have 6 to the negative 3, y to the 4th, and we're dividing by 7x to the 2nd, y to the negative 7. So I'll leave the outer exponent the way it is for the moment. 6 to the negative 3 is, in the numerator, is equivalent to 6 to the positive 3 in the denominator. So in this step, I'll leave the 7 in the denominator and write 6 to the positive 3 in the denominator. We already have y to the 4th in the numerator. We're starting out with y to the negative 7 in the denominator, and that's equivalent to y to the positive 7 in the numerator. Okay, we'll simplify a little bit more before applying the outer exponent. So in the numerator, we have this outer exponent too. In the numerator, y to the 4th times y to the 7th is y to the 11th. So when we're multiplying two terms that have the same base, y, we add the exponents. 6 to the 3rd is 216. So 7 times 216. And then if we apply the outer exponent, we'll get y to the 22nd, because 2 times 11 is 22. We multiply those exponents. And in the denominator, I'll just write 7 to the 2nd times 216 to the 2nd. So this is an okay answer. Since you're allowed to use a calculator, you can figure out what 7 to the 2nd times 216 to the 2nd is. But even on a test, this is an okay answer. What's that? What are you looking at? I don't get it. Oh, there's yeah. Yes. It was pointed out that I did not see the x squared here. Wonder how I missed that. So yeah. So this step would have a x to the 2nd in it, in the denominator. So if we just go directly to the final answer, the denominator will have x to the 4th. Yeah, thanks for pointing that out. Okay, on the next one, let's simplify what's on the inside of the parentheses. We'll deal with the outer exponent -3 in a minute. We have numerical factors. We have 5 in the numerator and 2 in the denominator. We have x to the +5 in the numerator. X to the -2 in the denominator is equivalent to x to the +2 in the numerator. And then y divided by y to the 6th, that's equivalent to y to the +5 in the denominator. Okay, we'll simplify a little bit more in the numerator. The x to the 5th times x to the 2nd. So in the numerator, we have 5 times x to the 7th. In the denominator, 2 times y to the 5th. And the outer exponent is -3. Okay, now we deal with the outer exponent of -3. So what we can do is we can write the reciprocal of the rational expression. That means we'll have 2y to the 5th in the numerator, 5x to the 7th in the denominator, and we change the outer exponent to +3. Okay, then when we apply the outer exponent +3, we're going to multiply it by each of the exponents on the factors on the inside. So we'll get 2 to the 3 times 1, 2 to the 3rd power, times y to the 3 times 5, or 15. In the denominator, 5 to the 3 times 1, or 5 to the 3rd, times x to the 3 times 7, or x to the 21st. And then we'll simplify the numerical parts. 2 to the 3rd is 8. So the numerator is 8 times y to the 15th. And the denominator, 5 to the 3rd, is 125. And then x to the 21st. Okay, so that's as far as we can simplify that one. Okay, we'll multiply some polynomials. So on this one, 5u minus 4v multiplied by 2u plus 3v. So start with 5u and multiply it by the other binomial. So 5u times 2u is 10u to the 2nd. And then plus 5u times 3v is plus 15uv. Then we multiply -4v times the binomial. -4v times 2u is minus 8vu, but that's the same as uv. And then minus 4v times 3v is minus 12v to the 2nd. We can simplify further because the middle terms are like terms, so our final result is a trinomial, 10u to the 2nd plus 7uv minus 12v to the 2nd. In the next one, we're multiplying a binomial and a trinomial. So start with x and multiply it by every term in the trinomial. X times x squared is x to the 3rd. And then minus x times 6x is minus 6x squared. And then minus x times 7 is minus 7x. And then we're going to multiply -5 times the trinomial. -5 times x squared. We can write it over here, minus 5x squared. Negative 5 times negative 6x is plus 30x. And finally, negative 5 times negative 7 is positive 35. There are some like terms that can be combined. The minus 6x squared minus 5x squared is minus 11x squared. And minus 7x plus 30x is plus 23x. And then plus 35. This is our final result. Okay, the next one, 3m minus 7n quantity squared. So this means that we're multiplying 3m minus 7n times 3m minus 7n. So we start by multiplying 3m times the other binomial. 3m times 3m is 9m to the second. And then minus 3m times 7n is minus 21mn. And then minus 7n times 3m is minus 21mn again. And then negative 7n times negative 7n is positive 49n to the second. The two middle terms are like terms, so they can be combined. And we get 9m to the second minus 42mn plus 49n to the second. Remember, whenever you square a binomial, the result is a perfect square trinomial. Okay, the next one will also end up with a perfect square trinomial because we're squaring a binomial, 6r plus 5t times 6r plus 5t. So 6r times 6r is 36r to the second. And then plus 6r times 5t is plus 30rt. And then plus 5t times 6r is plus 30rt again. And then lastly, 5t times 5t is plus 25t to the second. And combined by adding the middle terms, so we get a perfect square trinomial, 36r to the second plus 60rt plus 25t to the second. Okay, now we start to factor. So factor each polynomial completely. 49y to the second minus 84y plus 36. So we might wonder if this is a perfect square trinomial because the term on the left is a perfect square, 7y squared, and on the right, plus 6 squared. So if it is a perfect square trinomial, the middle term has to have the form minus 2 times 7y times 6. And sure enough, if you multiply negative 2 times 7y, you get negative 14y. Negative 14y times 6 is negative 84y. So it is a perfect square trinomial, so its factors are identical. They will be 7y minus 6 times 7y minus 6. And you can check by multiplying. Okay, the next one, a to the second plus 25ab plus 46b to the second. So on this one, we'll try the AC method. So multiply 1 times 46. And we want to see if we can find two integers that have a product of 46 and a sum of 25. So both numbers must be positive if the two integers exist. So 1 times 46 is the first pair, then 2 times 23 is 46, And those two add up to 25. So that means we can factor this. So rewrite this as a to the second plus 2ab plus 23ab, and then plus 46b to the second. And factor by grouping. Out of the first two terms, we can factor out a, and the other factor is a plus 2b. Bring down the middle operator of addition. Out of the third and fourth terms, we can factor out 23b. And we're left with a plus 2b. And then the final factorization, a plus 2b times a plus 23b. Okay, we're out of time for today. We'll get through as much as we can on the rest of the test 2 review sheet tomorrow. But that is all for today.